Okay, in this chapter, estimation and confidence interval. So here in this chapter, we're going to focus upon finding a confidence interval for a point estimate. So this is the focus in this chapter. So we begin by saying that in this chapter, we begin by studying point estimates. What is a point estimate? Of course, a point estimate is a single value or point that is derived from a sample and used to estimate a population value. Most cases, the population value is unknown. Therefore, we need to select a sample, okay, calculate a point estimate of the mean or the standard deviation of the mean, and so on and so forth, in order to estimate the unknown mean of the population or the unknown standard deviation of the population. So we have to basically select a sample, a random sample, and calculate the point estimate of the statistics that we are after. An informative way is to list a range of values in which we expect the population parameter to take place. Okay, instead of just finding a point estimate to estimate the population parameter, a best or an informative approach or way is to basically list a range of values in which we expect the population parameter to take place, inside this range. Such a range of values is called the confidence interval. Therefore, a confidence interval is a range of values that consist the population parameter. So within that range of values, we expect the population parameter to take place. So let's talk about this topic, point estimate for a population mean. An example that illustrates, the point estimate, that illustrates the finding and the importance of a point estimate. Let's say the example, since recent medical studies indicate that exercise is an important part of a person's overall health. Yes, indeed. This is recent studies shows that exercise is an important part of an individual's overall health. Therefore, the director of human resources at Al-Ayyub, the Lebanese International University, wants an estimate of the number of hours per week staff spend exercising. So the director of human resources would like to know the number or wants to an estimate of the number of hours per week staff spend exercising. So what happens? She selects a sample of 25 staff in the university, and that sample of 25 staff reveals the mean number of hours of exercise last week is 2.6 hours. So the sample, when she selected a sample of 25 staff, of course, in the university, and that sample reveals the mean number of hours of exercise is 2.6 hours. Therefore, the point estimate of 2.6 hours estimate the unknown population mean. The point estimate of 2.6 hours, of course, estimates the unknown population mean. So that 2.6 hours, the mean number of hours of exercise of that sample of 25 staff, estimates the population, the unknown population mean. As I said, the population mean or the population standard deviation or the population proportion is unknown, and we would like to estimate that unknown, parameter. Since a point estimate tells only part of the story. Okay, tells only part of the story. Therefore, a confidence interval can serve the purpose of expecting the point estimate to be close to the population parameter. A confidence interval, so now a point estimate is just part of the story. Therefore, to make sure that the population parameter that you would like to estimate is within a certain range, therefore a confidence interval would serve that. What is a confidence interval? A confidence interval is a range of values built from sample data so that the population parameter is likely to take place within that range at a stated probability. The stated probability is called the level of significance. The level of significance. Of course, shortly we will show how to find, the confidence interval. Okay. To calculate the confidence interval, we consider two cases. Here in this chapter, when we want to calculate the confidence interval, we would like to talk about two situations, two cases. The first case, of course, we use the sample data to estimate mu, the mean, with x, bar. And the population standard deviation is known. So the first case or the first situation is that, we want to find the confidence interval when the population standard deviation is known. The second situation or case is that, when the population standard deviation is unknown. How to formulate the confidence interval when the population standard deviation is unknown. So we have two cases. The first case, formulating the confidence interval when the standard deviation of the population is known. And the second situation or case is formulating the confidence interval when the population standard deviation is unknown. Now, the case when the population standard deviation sigma is known. When sigma is known, that is, the population standard deviation is known. A confidence interval for the population mean. The population mean is unknown. Okay, and we estimated with the population, with the sample mean. So a confidence interval for the population mean when the population follows the normal distribution and the standard deviation is known is computed by using the following formula. So the formula for calculating or computing the confidence interval of the population mean when the population standard deviation is known is given by the following formula. X bar plus or minus z times sigma over radical m, where z denotes the level of significance. Of course, shortly I will show you how to calculate z, for different level of significance. Remember that sigma x bar is equal sigma over radical m. Sigma over radical n, we're going to denote this with sigma x bar. This is the symbol. Sigma x bar is the symbol for the standard error of the mean. So sigma x bar, which is equal sigma over radical n, is the standard error of the mean. Sigma x bar is the symbol for the standard error of the mean, which is equal sigma over radical n. It is, as you can see, this one is affected by two factors. Sigma, the standard deviation of the population, and the n, which is the sample size. The sample size. As you can see, when the sample size is large, the greater or the larger the sample size, then the lower the standard error of the mean. Okay, now our topic is how to find the z-value for a particular level of confidence. Okay, so in this lesson, we're going to encounter many problems concerning, finding the confidence interval. Okay, so we're going to have many levels of confidence intervals. So how to find the z-value corresponding a certain level of confidence interval. Example, find the z-values for a 92%, 95%, and 99% confidence intervals. So here we're going to give an example of how to find the z-values for different levels of confidence intervals, namely 92%, 95%, and 99%. Of course, once you know how to apply these to find the z-values, you can apply it for any other confidence interval. So let's focus over here. So remember the following here. The z-values are calculated from the table in the appendix P1. Here we have a kind of a simplified portion of the z-table in appendix P.1. I have a kind of a simplified portion of that, big table in appendix P1. Now, the z-table, of course, is based on half of the normal distribution. The z-table is based on half of the normal distribution. So if the level of confidence is 95%, how are we going to find the z-value if the level of confidence is 95%? So the very first thing what you do, because the z-value is based on half of the normal table, then the very first thing we've got to divide the level of confidence by 2. So we 0.95, which is 95%. We divide this one by 2, we come up with 0.475. This value, of course, this value is in the body of the table. So what we do, we go to the table over here. The value of z that matches 0.475 in the body of the table is 1.96. So once we divided the level of confidence by 2, we come up with 0.475. Why we divide by 2? Because the z-table is based on half of the normal distribution. Okay? Now, we take this number 0.475 and we look up this number in the body of the table. 0.475. Come up here. 0.4750 is over here. This one here. This is the value of z. This is the probability. The probability of finding a z-value that is 1.96. Now, 0.475 is located here. This is of course, the area or the probability of finding a z-value. What is that z-value? Of course, what we do, we move up in this column. Okay, this is the value over here. It's 1.9. Go along this row until 1.96, and then we go up in the column all the way up to 0.06. So the value of z is going to be 1.96. This is the probability, 1.96 is the probability of finding, of course, a z value between 0 and 1.96. So as you can see, the probability of being between the interval minus 1.96 and 1.96 is what? Is 0.95 or 95%. And the probability of finding a z-value of 1.96 is 0.475. The probability of finding a z-value of minus 1.96 is 0.475. Clear? So this is the normal distribution. The area from here, the area that corresponds to a z-value of 1.96 is 0.475. The area that corresponds or matches the z-value 1.96 is 0.475. Or the probability of finding a z-value between 0 and 1.96 is 0.475. It's clear? Now, what about if the confidence interval is 92%? How are we going to find the z-value if the level of confidence is 92%? So the same thing, the very first thing, because the normal distribution, the z-value is based on half of the normal distribution, what we do, we just divide 92% over 2. 92%, 0.92 over 2, we come up with 0.46. We take this number to the body of the table, okay? Actually, some number, perhaps you can find the same number here, or very close, the closest number to 0.46, okay? So look over here, we kind of, we find, of course, this is the number, 0. It's going to be 1.75, 0.4599, which is very close to 0.46. This is the number here. This is the number. 0.4599 is very close to 0.46. 0.46. The number that approximates 0.46 is 0.4599. So actually, perhaps you will find the same value or a very close value to the half of the value of the level of confidence. So now we look over here. Okay, what we do to find the z-value corresponding to 0.4599 is going to be equal. We move up, okay, up along the column here until you get, you touch 0.05, and then you move, to the left along the row until you find 1.7. So 1.75 is the z-value that corresponds to 92% confidence interval. And then as you can see over here, the probability of finding a z-value between 0 and 1, and the probability of finding a z-value between 0 and 1.75 is 0.46, or the closest number to it, which is 0.4599. Is that clear? This is how you find the z-value that correspond to 92% confidence interval. Because in the table here, okay, the body of the table corresponds to values of the probabilities of finding a z-value between 0 and of course 1.75 here, or here between 0 and 1.96. Now, what about if the confidence interval is 99%? Okay, how are we going to find the Z value that matches or corresponds to the 99% confidence interval? So what you do, the first step is to divide, 99% or 0.99 by 2, we come up with 0.495. And then we take this number 0.495 to the table, the body of the table in the appendix B.1, okay? And we come up, we look over here, where is 0.495? 0.495. Here, you look at a very close number to it, or perhaps you might be lucky to find the same value in the table. Now, it looks that we have to look for a close number to this to 0.495, which is 0.495 is going to be 0.4951. Here. This is, of course, the, to find the value of Z, you just, move to the left along the row until you get 2.5, and then move up in this column, you find 0.08. So the value of Z is going to be 2.58. 2.58. 2.58. So this is the value of Z that corresponds to the 99% confidence interval. Now, the probability of being between the intervals minus 2.58 and 2.58 is what is 99%. Or the probability of finding a Z value between 0 and 2.58 is going to be equal to 0.495. 0.495. Or the area that corresponds to a Z value of 2.58 is 0.495. The area that corresponds or matches 2.58 is 0.495. Now here, kind of a summary of the Z values that correspond to a certain level of confidence. The table here illustrates the values of Z matching different confidence intervals. So for instance, if the confidence interval is 92%, then the nearest half probability is 0.46. And the Z value that corresponds to 0.46, or the Z value, the Z value is going to be 1.75. Okay? So the probability of finding a Z value between 0 and 1.75 is 0.46. The same thing, if the confidence interval is 94%, then the nearest half probability is 0.4699, and the Z value, of course, is going to be 1.88. You're finding the same way we went through it here. The same thing, if we have 95% confidence interval, we already calculated this one. We come up with, of course, we come up with 1.96. If we have 95% confidence interval, then the nearest half value is 0.475. We already calculated this one when we, of course, work with the problem, the example a minute ago. The same thing, if you have 99% confidence interval, then the Z value corresponding to this is 2.58. Okay, now we're going to, of course, solve some problems regarding, the confidence interval when the population standard deviation is known. So we have two examples here. The first example, of course, says the following: the planning department at Juices and Cocktail Company reports that distribution of weekly sales of its restaurants follows the normal distribution, and that the population standard deviation is 2,500. a sample of 50 showed the mean weekly sales to be $40,000. Now we have some questions regarding this problem. First, what is the population mean? B, what is the best estimate of the population mean? What is this called? What do we call this population? The estimate of the population. C, develop a 95% confidence interval, CI, for the population mean. Interpret the confidence interval. So the solution, as you can see, first of all, we want to, what is the population mean? Of course, we are to find the confidence interval for the population mean, which is unknown. Here we don't have the population mean, so the population mean is unknown here. Okay, the population mean is unknown. Now, if you look at the question here, we don't see any population mean. However, we have the sample mean, the sample average. Says, what is the best estimate of the population mean? Of course, the best estimate of the population mean is the sample mean, which is $40,000. Therefore, the best estimate of the best estimate of the population mean is the sample mean, which is $40,000. It is called a point estimate. It's called a point estimate. C, develop a 95% confidence interval for the population mean. So the population mean is unknown. We would like to develop a 95% confidence interval for the population. We need to find where it is located, what is the range of values that the population mean is located within. So the formula of the confidence interval, of course, is x bar plus or minus z sigma over radical n. Now remember, since we're talking about the 95% confidence intervals, I have already talked about how to find the z value for different values of confidence intervals. So you can go back and see exactly what we said and what we did in order to calculate the z values when we have different levels of confidence intervals. Here we have 95% confidence intervals. We have already calculated the 95% confidence interval to be z equal 1.96. So we plug the values here in this formula, x bar plus or minus z times sigma over radical n. Of course, sigma is the standard deviation of the, standard deviation of the population, which is known. Okay, here we're talking about the title here when the, sigma, which is the standard deviation, is known. So it is known. So we plug the numbers here. We come up with 40,000 minus 1.96 times 2,500 over radical 50. Plug all the numbers. The other, limit of the range, the interval is 40,000 plus 1.96 times 2,500 over radical 50. Of course, we'll get this, these limits, the lower limit and the upper limit, and we can put them like this, write them like this, which is 40,000 plus or minus 693.1. So this is the interval that we are sure that the population mean will be included within this range. Now, of course, interpret the confidence interval. Here, problem or example 1, part B, we say about 95% of the intervals similarly constructed would contain or include the population mean. Okay, 95% of similarly constructed intervals will include, the population mean. This is the interpretation of the confidence interval. Now, we have another example here, example number 2. It says the LIU administration, it is the university, Lebanese International University, is interested in estimating the number of misconduct cases in the final exam at LIU. You would like to know, the mean number of, misconduct cases as far as cheating or something like that at LIU campuses. A random sample of 500 exams was selected from different branches of the university. It revealed an average X bar of 53 misconduct cases. It is known from previous records that the population standard deviation sigma is 10. So here we say that the population standard deviation is known. So once we know that it is known, then we can use the formula, which is X bar plus or minus Z sigma over radical n. Assume this distribution follows the normal distribution. Great. Now, we have the following questions regarding this problem. First, determine the population mean. What is its best estimate? What is it called? Of course, the population mean is unknown, as you know. Its best estimate is the sample mean. Of course, it is best estimate. It is the sample mean, which is equal X bar equal 53. Okay. This is the best estimate of the population mean, which is unknown. The population mean is unknown. Its best estimate is the sample mean, which is equal 53. Let's call that case. What is this called? It's called a point estimate. Okay, great. B, determine the standard error of the mean. The standard error of the mean is, sigma X bar is equal to standard error mean. This is here, standard error of the mean. A sigma X bar is equal sigma over radical n. So we have sigma here 10 over radical n 500, and we come up with 0.447. This is the standard error of the mean. Now, part C, deduce the margin of error E. The margin of error E, of course, here, we can say here, E the margin error E is equal to Z or Z, the value that is, calculated, times the standard error of the mean, Z times sigma over radical n. We have already calculated the standard error of the mean, sigma over radical n, to be 0.447. What we do now, Z, of course, Z is calculated. Of course, I have already talked about how to calculate the Z values. The Z value when the level of significance is 95% is equal 1.96. Go back and look or listen to the video regarding how to find or calculate the Z values at different levels of confidence intervals. So we plug the numbers here, we come up with 1.96 times 0.447, we come up with 0.876. This is the margin error. Now, D, construct the 95% confidence interval of the population mean. Of course, you plug the formula over here, X bar plus or minus Z, sigma over radical. We come up with 53 plus or minus 0.876. which is, we have the lower limit here and the upper limit here. The lower limit is 52.124, and the upper limit, of course, 53.876. So as you can see, the range of values that we expect the population, mean, to be is this, from 52 to 53. This is, we expect the population mean to be within this range. Now, interpret the confidence intervals like we did with the previous question, where we can say about 95%, this is the interpretation, we say about 95% of the intervals similarly constructed would contain the population mean. Of course, you use this type of statement to indicate the interpretation of, the confidence interval. Now, would it be reasonable to conclude that the average number of misconduct cases across all IU branches is 55? Well, as you can see, 55 is outside this range. 55 is outside the, the confidence interval or this kind of range. Therefore, we say no, it would not be reasonable because 55 is outside the confidence interval. Okay, still, we are, solving problems concerning, the confidence interval when the standard deviation of the population is known. Problem number 3, suppose you wish to estimate the average annual salary for school teachers in the United States. Suppose you took a random sample and found that the mean is 53,145. The mean of, school teachers, the mean of, salaries of school teachers is $53,145. Assume that the population standard deviation is 16,451. We have 3 questions concerning this problem. Part A, find a 95% confidence interval for the mean salary. Okay, since, of course, the standard deviation of the population is known, then we use the formula that we have already used, which is x prime plus or minus, z times the standard error of the mean, which is sigma over radical n. So now he's saying find the 95% confidence interval for the mean salary, given that your sample has size n equal 36, n equal 64, n equal 144. So as you see here, we need to find the confidence interval when n increases, starting from n equal 36 all the way until n equal 144. So what is the confidence interval when n equal 36, when the size of the sample is 36? What is the confidence interval when the size of the sample is 64? Okay. What is, the confidence interval when the size of the sample is 144? Now, of course, when n solution here, part A, when n equal 36, the confidence interval, CI, confidence interval, is x bar plus or minus z times sigma over radical n. Z times sigma over radical n is the standard error, is the margin error, okay? Where sigma over radical n is the standard error of the, the mean. Now, so we plug the values in this formula, and we come up with 53,145 plus or minus 196. Of course, z is 1.96. We have already talked about how to calculate z values when we have different confidence intervals. So when we have 95% confidence interval, the z is 1.96. The Z is 1.96. So plug 1.96 times 16,451 over the square root of 36. We come up with, this is the range or the confidence interval, of course. Now, when n equals 64, the confidence interval is going to give us 53,145 plus or minus 2056.3. When n equals 144, and we plug the values, we come up with confidence interval. This is the range, 53,145 plus or minus 1,370. Of course, just a brief look at these values of these confidence intervals, you would see that the confidence intervals, of course, decreases. Of course, it decreases. We will see that, the answer of the next question. Now, of course, part B says compare the margin of errors of the three intervals, and we need to put the conclusion. Now, the margin error when n equals 36 is 2,741. The margin error when n equals 64 is 2,056.3. The margin error when n equals 144 is equal to 1,370.9. So as you can see, the values of the margin error, decreases as n increases. Conclusion: the margin of errors decreases as n gets larger. Okay. C, does the confidence interval get longer or shorter as the sample size increases? Is that what would you expect? Of course, here it gets shorter, as you can see. Why? Because the margin error decreases as n increases, so the confidence intervals gets smaller or shorter as n increases. One should expect that, because as n increases, the better it is chance of precisely representing the population. Now, we go to the problem number 4. Problem 4 says a cookies factory is concerned about absenteeism, about people who usually miss their work or, are absent from coming to their work among its workers. Okay? To find the mean number of absence days in the population, of course, to know the mean number of absent days in the population, all we have to do, we take a sample. So we take a sample of 10 workers. 10 workers was chosen and studied during the last 2-week period. Okay? Now, as you see, the sample shows an average of 1.8 days absence with a standard deviation of 1.1353. So here we know, as you can see, that the standard deviation is known. Now, the sample shows an average of 1.8 days absence. So now determine the sample standard error of the mean, which is S x bar. This is the standard error of the mean. Of course, S x bar is equal to sigma over radical n. Sigma is known, 1.1353 over radical n, because the sample size n is 10 workers, and we come up with 0.359. Determine the margin error at a 95% confidence level. Of course, the marginal error is going to equal Z times the standard error of the mean. So because we have 95% confidence interval, so the Z, we have already talked about that. So the Z value, when the confidence interval or the confidence level is 95%, it's going to be 1.96. So we plug here 1.96 times the the standard error of the mean, we come up with 0.704. Okay, 0.704. This is the standard error of the mean. C, determine the 95% confidence interval for the population mean. Of course, we have already calculated part of the formula, which is the margin error. So all we have to do, we just plug the formula, which is x bar plus or minus z times sigma over radical n. Z times sigma over radical n is the margin of error. We have already calculated that in part B. So plug the values and we come up with 1.8 plus or minus 0.704. And so we have the range, we have the lower limit 1.096 and the upper limit 2.504. This is the confidence interval. Part D, would it be reasonable to conclude that the population mean is 1.5? Well, yes. As you can see, 1.5 is within this range. Okay? So yes, it would be reasonable to conclude that the population mean is 1.5, since this value, of course, is within the range of values of the confidence interval, which is 1.096 and 2.504. So yes, indeed, it's reasonable to conclude that the population mean is 1.5.